All right. Good afternoon, everyone. It's great to be in Vilnius. I've been here for this is my third day. I'm really enjoying it. First time visiting, and I know it will not be the last one. So my name is Borja Burgos. I am a product manager at Datadog, and today I'm going to be talking to you about shift left observability. Um, who's ready to learn something about shift left and observability? Quick show of hands. Everyone, come on. I know this is after lunch, so everything's gonna be a little slow. I'm gonna try and keep it high energy to make sure that everyone's engaged. I put a few jokes in my talk, so let me know what you think after the talk. So before I start talking about this shift left observability, whatever that is, I literally picked some random buzzwords from a bag. So like, okay, what can I talk about? And it was like shift left observability. Let's put those together. I'm kidding. I did not do that. But before I tell you a little bit about this talk, I do want to tell you a little bit about me because it's somewhat relevant. While I would not dare to compare myself against or to the great Steve Ballmer and his epic developers speech on .NET, there's one thing that Mr. Ballmer and I do share, and that is our love and passion for developers. Now you may be thinking, hey, I'm at the DevOps track for this conference, not the developer days. But developers, as we all very well know, are a key part of DevOps. So I'm passionate about developers. I'm passionate about the developer experience, and hopefully that shows through this presentation. So I started my career as a software engineer myself, and quickly became very frustrated with the state of developer tools, to the point where I decided to leave and stop being a developer to build developer tools. I've been building developer tools for most of my career. I founded a company in the early days of the container ecosystem at the cross section of infrastructure and developer tools called Tutum. And what Tutum aimed to do was to make it very easy for developers to package and ship an application to the cloud. Now, that's something that we take for granted today, but back in 2013, 2014, doing so was not as easy. Tutum got acquired by Docker, and I went to work at Docker for a few years. Working at Docker was great. I was able to work on their cloud offerings, Docker Hub, Docker Cloud, some of their enterprise software, as well as their developer tools, Docker for Mac, Docker for Windows, which some of you may be using today. But still at Docker, I grew frustrated with the developer experience. While we were great at being able to figure out when something fell in production, why it failed, how to fix it, we had metrics, we had structured logs, we had distributed traces to be able to quickly hone in and identify what the issue was in production. When it came to development, it was horrible. We were building relatively complex distributed systems. Our CI was complex, our tests were complicated, but oftentimes we would have failures in CI that would take our engineers days to fix. We would spin up infrastructure, we would run complicated integration tests, and that was a black box. Things would break, and all we had to go to debug these things were the logs from Jenkins. So I asked myself, given how much visibility we have into our production systems, why is the developer experience so bad in CI? And so I left Docker to start another company, Undefined Labs. We built a product to provide visibility and instrumentation for development to be able to understand why our tests are failing, why our builds are taking so long. Fast forward to today, that company got acquired by Datadog, where I am today working on the cross section of observability and developer tools, which brings us to this talk. So, what is shift left? Shift left is nothing but the idea behind taking things that have traditionally been done on the right-hand side of this diagram, that is that side of this diagram, and shifting them left. So I'm sure you have heard of things like shift left security. That is, why wait until our applications are running in production to see if they have a vulnerability? Why don't we run those scans earlier in the development workflow? Or shift left testing, right? Why wait until we have shipped this application to production to see if there's a quality issue or regression with that application or user acceptance tests? Can we actually run those tests, those synthetic tests, earlier as part of the development workflow so that we're able to catch regressions early on. And why do we want to catch regressions early on? Ultimately, it is proven that the earlier we catch a regression, the earlier we fix it, the more the cheaply it is to fix it, right? So the cost of fixing an issue for a developer, if I'm working on my IDE and I get a message from my IDE that says, hey, that dependency that you just added has a known vulnerability, great, I can literally fix it right there. It takes me a few seconds. Now, if we wait for that to be at the code review level on GitHub or GitLab as part of a PR, that's going to take a little longer. If we wait until that's gone through CI and CI fails, sure, I can still fix it, but it's going to take a little longer. And if we wait until that application hits production, has a security issue, potentially customers are exposed to it, that could have a horrible impact on the company financially, and it's going to take a much longer time for the team to fix it. So shift left is ultimately all about, let's move things that, again, traditionally we've done later on the development workflow in the software development lifecycle and move them earlier to be part of development. So what is observability then? I'm sure you've seen talks where observability is defined as the combination of metrics, logs, and distributed traces. And while that is not necessarily false, I like a little bit more descriptive, pragmatic approach. I think of observability as the tools, best practices, and the processes that we can use to understand the behavior and the state of any given system. So you can think of observability as a magnifying lens, like in this diagram, that allows you to actually look into the system and see what's happening through the use of metrics, logs, and distributed tracing, as well as other data. You can also think of it as flashing a flashlight to your system and actually seeing what's inside, or even a light bulb, turning the light on into a system to actually see what's happening. Now, speaking of light bulbs, for this presentation, given how popular large language models and AI have become in the recent months, I wanted to run an experiment. I said, hey, can I use large language models, things like OpenAI, to help me in my presentation? So I had OpenAI generate a few jokes for my presentation, and I used Midjourney, which is a generative AI that creates images, creates some images that go alongside the joke. So speaking of light bulbs, here's my, or rather OpenAI's first joke. How many developers does it take to replace a light bulb? And those are all images created by Midjourney when I typed the prompt, a software developer replacing a light bulb. Anyone, any guesses? It is a horrible joke. You may have already heard it. No one? I can only see so many of you. So if you do have an answer, just yell it. No? All right. None. It's a hardware issue. How bad of a joke is that? Come on. If anything, we can laugh that it is a pretty bad joke. Um, so those still, the images that Midjourney created, I think, were pretty cool. So that's the first joke. I've got more for you coming in a few minutes. So shift left observability. It's the combination of this idea of shift left principles and observability, right? Observability has traditionally only been applied to production. We create these metrics, we have distributed tracing logs to observe our production systems. But it's very uncommon today still to use observability tools, best practices, and processes to shift left and look into our development workflows. How are we building these applications? Why is CI and CD slow? Why is it failing? Why are builds flaky? So why do we need shift left observability? I'm going to give you a couple examples that you may relate with. How many developers in the audience? Really quick, show of hands. Okay, so we've got a number of developers. I am convinced you are familiar with this. You have seen this in the past, whether it's a Slack or an email. You build, you commit code, it goes through CI. 10 minutes later, 30 minutes later, 5 hours later, however long your CI takes, you get a message saying, hey, your build failed. And then you click on it. And that's where the problems begin. Now, you would hope that you'd see an explanation of why it failed. the root cause behind that failure, how to fix it. But no, when you click on that message, you're most likely going to be presented with a dump of the logs of the pipeline. And it's going to look something like this. And then you're on your own with a Control F, failure, error, exception. What am I looking for here? I don't know. So again, what this is something that shift left observability. Hopefully, after this talk, you'll be able like, oh yeah, it can definitely help. How many platform engineers, developer experience, platform engineers, developer center of excellence, the different names, but like teams that or folks here that own the CI/CD process and the developer experience process? Any people working as a platform engineer type? Okay, so then you'll relate to this next one here. This also was a picture that Midjourney generated. I said a group of angry software developers, and this is what I got. So CI/CD is too slow. My tests are not flaky. Why are the builds flaking? Where's my commit? I committed 3 days ago. It's not in production. Where is it? Why did my build fail? Dora, I don't even know why I'm yelling Dora, but Dora, you may be familiar with Dora. Dora, I won't go into too much detail here, but a few years ago, a set of very smart folks wrote a research paper on the key metrics that are indicative of a high-performing engineering team. And if you do well in those 4 metrics, you're a high-performing engineering team. So now there's a whole trend about tracking those metrics and making sure that you actually are doing well. Those metrics are namely mean time to resolution, mean time between failures, change lead time, and deployment frequency. So, Dora. Why don't we have Dora? So shift left observability will help you with all these things. Meaning we got the ability to detect problems earlier. We've got the ability to reduce mean time to resolution, increase mean time between failures, and accelerate your software deployment. But most importantly for me, and should be for all of you, the one in the middle, shift left observability increases developer happiness. And that's all I care about, making developers happy. If your developers are happy, you will be building better applications. Those applications will make it to production even faster. So speaking about happy developers, here's joke number 2. Are you ready? This one is even worse than the first one. Oh, whoa, I jump ahead of myself. So some of you may not know what a happy developer looks like. So I asked Midjourney to generate a few pictures of a happy developer. I said, hey, Midjourney, imagine a happy software developer. That's all I said. A photograph of a happy software developer. And now I got a few dozens of these. I selected a couple. There were a few things that everyone had in common. They all had a beard. They all had glasses. And they all happened to be male. So there's definitely some bias built into these systems. Interestingly enough, this individual here also has a bit of a cyborg-looking finger. I'm not really sure what's going on there, but we'll give Midjourney a pass on this one. Luckily, there is some racial diversity for Midjourney, so we did get some of that, which was reassuring. I'm thankful for that. So here's another happy software developer, in case you're wondering what they look like. And then I explicitly asked Midjourney to show me a happy female software developer and see what it turned out. And hey, guess what? She's got glasses. So keep that in mind. So now that we're talking about happy software developers, here's the next joke. Why do software developers not like nature? Woo! We got a winner right there. Nice. Well done, well done. I actually do like the picture that Midjourney generated for this. This one was a bigger prompt. I asked something along the lines of a software developer in front of a desk in nature in the forest, surrounded by bugs. And I got some pretty cool drawings for that one. All right, going back to topic. So shift left observability. You now know briefly what it is, but okay, Borja, show us some real world examples of what this actually looks like, right? What can we actually do with this? And how is it going to enable us to build and ship better software faster? So I've got a few examples to go through. Now, this is not a comprehensive list. And if there's one key takeaway of this talk is that there's no right or wrong way of doing shift left observability. Ultimately, it's about the principle of measuring and getting data, whether it's metrics, logs, distributed traces, earlier in the development workflow, right? You want to start to understand what's actually happening. So one of my favorite experiences, one of my favorite examples of using shift left observability came from integration tests. At Docker, we had a challenge. As I mentioned, we would spin up a complex distributed system. We would run integration tests. Those tests would fail, and it would take us days to figure out why they failed. So what we did is we instrumented our services and our test frameworks with distributed tracing. What you're seeing here is a distributed trace. You may be familiar with this from products from like APM type solutions. The very top span, though, that is not a request. The very top span actually represents the test. The spans underneath are the actual requests generated in the context of that test. Meaning if my test has an HTTP request, a gRPC request, a SQL query, I can actually see this contextualized in a test. Different colors represent different services. So if my integration test touches 3, 4, 5, 7 different services, I can see this. Meaning that when that test fails, because 7 services down and service through an error 500, I actually have the context of the entire trace, everything that happened, for me to be able to debug this. In this example, we can see that the error actually stems on the bottom from a service that is authentication service. As a developer, I may be familiar with the authentication service, and I may be able to fix this given that I have the exception that was thrown. But maybe I have not a clue what the authentication service even does. But I can now deep link, send this to the team that owns that service and say, hey, I was running this test and this is what happened. And they have everything at their disposal to be able to fix it, meaning they don't have to try and reproduce this, which would take, again, many, many hours, if it's even possible. Because sometimes, the versions of these dependencies may have changed. So just trying to figure out what was running at the time in which a test failed is hard in itself. Another use case for shift left observability is to bring all the richness and the data that we have in production into the IDE. What are some examples of this? Say that you have a continuous profiling solution, something that is taking profiles, CPU, memory profiles in production. Wouldn't it be great as a developer when I'm working on my IDE and I'm about to touch a function, if my IDE tells me, hey, Borja, by the way, before you touch that code, 75% of our production code or of our production requests actually go through that function. That is on the critical path. Maybe I'll drink a quick shot of espresso and a coffee before I actually start touching that code, right? That is context that as a developer right in the IDE is very, very useful. Similarly, if you tell me that, the code that you're about to touch gets called 0.1% of the times in production, maybe I don't need that additional coffee. You could use this also to say code coverage. This code, which is critical in production, is not covered by any tests. Well, that's useful information to know right now when I have the IDE open. I don't have a screenshot, but other teams that I've been working with are also using this in the context of code reviews. So as a code reviewer in GitHub or GitLab, you have a pull request or a merge request, and I'm in charge of reviewing code from one of my peers. Could you imagine in that context of the code review, you see the same message. Hey, you're about to review code that is in the critical path for production. 75% of the calls that go through production actually go through this code. As the code reviewer, again, I'm more likely to pay attention and have a more detailed review of this code. So this is one way in which you can use information that you may already be collecting and shift it left to the developer workflow to make the developer experience better. Tracking test failures and flakiness. I'm sure everyone here has experienced flaky tests. If you say you haven't, you're lying. That's right. So I work with teams that are like, hey, our code base is too flaky. What can we do about it? Well, it's very easy to lightly instrument your test frameworks to automatically say rerun a test when it fails, to log this data into your existing observability platform and say, hey, this test, we run it 5 times. it fails once. To be able to track when flakiness is first observed, which commit introduce flakiness. And so we do these things and oftentimes work with teams and they say, we've got 8,000 flaky tests. What do we do? We're not going to fix 8,000 flaky tests. Some of them probably you cannot even fix. But having this data allows you to start triaging and actually prioritizing which tests have the most impact, right? It's not the same to have a test that flakes after 3 milliseconds and flakes 1 in every 100 executions than it is to have a test that flakes after 5 minutes and flakes 1 in every 2 executions. So you want to prioritize the latter. You want to prioritize fixing the tests that take a long time to fail and fail very often. And you can disregard the ones that don't flake very often and are also flaking very quickly. So this is another way in which you can bring those metrics and apply shift-left observability to, again, improve the development workflow. What are some other examples? This one I actually lived through, and I was very happy that we had brought some of this visibility into our teams before it happened. So here's the scenario is we have a developer, they have a new feature, they write some new code, they change a SQL query as part of that code. The code goes through CI, it passes, nothing fails. Normally this would have gone to production unnoticed. But we had actually started to measure and provide alerts on regressions on test timing data. So we had a specific test here that used to take, say, 1 second, and I took 4 seconds. So we captured that regression, and we actually created an alert for the developer to come take a look at this. The issue was the actual SQL query. So he had changed the query, and where it took 187 milliseconds, now it was taking 774 milliseconds. Again, this difference in timing in the scope of a CI pipeline execution was unnoticeable. Nothing had failed, the test had passed. But had we actually shipped this to production, this would have had a negative impact on our users. The fact that we were able to capture this as part of that CI workflow meant that we could fix it without any user impact. So this is another way in which measuring and getting metrics allows us to fix issues before we actually ship them to production. Another regression, similar regression here, was with the size of an artifact. We had a developer, this one also was one of my teams, and he needed a tool that was not available in the container image that we were using. So he changed the base image. And he changed the base image to the full feature OS image, the one that weighs 2.6 gigabytes. And he had the tool that he needed. He was happy. So he committed the change. Now, that would have gone through CI normally. Nothing failed. Had we done that, we would have maybe noticed a few weeks later that our network bill may have gone up. And we're deploying these images hundreds, sometimes thousands of times a day. Believe it or not, when you have to pull a 235 megabyte image or a 2.6 gigabyte image, there's a difference in time. It takes longer to pull an image that's going to be 10 times longer. So that could have had some impact on the customers directly as well. Luckily for us, what we had done, and this was just a few weeks earlier that we had thought about this idea, we were emitting a metric, simple metric on every artifact that we built, whether it's a JavaScript bundle, a jar file, a binary of any sort, our Docker images. Every time we build anything as part of our CI, we emit a metric. We associate it with a tag to the specific pipeline and commit, and we just track that over time. And we send an alert. If the artifact that we're building is X% bigger than the historical average, then raise an alert. And that's what happened here. So we get an alert saying, hey, why is that Docker image 10 times the size? Oh, yeah, I changed this one thing. Well, let's revisit that decision, fix it right now before we actually deploy this to production. So that's another use case of using shift-left observability to gain insights into what you're doing in development. This one is for the platform team, right? Why is the stage so low? Once you start collecting information from your CI, you can start collecting every pipeline execution. You can collect information about the actual duration of every stage, the duration of every job. You can create custom graphs, such as this one, that show you waste time being spent? Are we deploying on the weekends? Is this stage that's meant to only be running overnight, running during the day? Is there any regression? Like here you can see, for example, that on between the 9th and the 10th of April, something happened. The build stopped running, so there was no pipelines running. So once you have the instrumentation, once you get the visibility from a platform perspective, it's very easy to actually understand what's going on, what's slow, how to fix it. I always tell people, I work with teams that they say, hey, we've got an initiative next quarter to improve our pipeline um, speed. We're going to make our pipelines faster. And I ask them, do you know how long they are on average today, how long they take? No, but we'll figure that out. It's this is overly stated, but I'll say it again. It's hard to improve anything that you can't measure. So step number one, measure where you are today and then look for improvement. But start to say have initiatives to improve things when you don't know where the baseline is will be very, very hard. And then I've got a few other examples. So hopefully this gives you some creative ideas as to how you can bring some of this data and apply it to your own teams. But you truly can apply shift-left observability to just about anything and everything in the software development lifecycle. So here's some other graphs that my teams are using. We've got an accumulated queue time per stage. So we want to know on average every stage, what is the queue time? Will this queue time be improved if we increase our CI infrastructure? Or are we constrained by the seriality of these stages, right? Are they being executed in a serial fashion, meaning no matter how much infrastructure we put in there, the queue time is going to be similar because they're just going to have to wait for the other stages to finish. Test performance, as I mentioned, metrics, you can plot these metrics. This is particularly useful for benchmark tests. I've worked with teams when I ask them, how do you track your benchmark test? How do you know if this number is better than the previous one? And they'll open up a spreadsheet. And they show me a spreadsheet with all the executions, historical executions. And that's challenging, meaning every time you run that benchmark, you have to go back, open that spreadsheet, write down, okay, it took me 300 milliseconds. Some other examples, top, slowest test. Again, in the context of trying to fix your code base, have developers say, every week we're going to grab the top 2 tests, slowest tests, and we're going to address them. And the fact that you're tracking this means that that developer that fixed that slow test can then go back to their team lead or their manager and say, hey, take a look at this. I did this code change, and this test that used to take 10 minutes is now taking 2 minutes consistently, and the change holds over many, many commits. That's a moment of pride for developers. One of the biggest changes I've seen with developers is most developers do not want to write tests because it's sort of adding work to themselves. I write a test, that's another thing that could fail. If it fails, I'm on the hook for fixing it, but I don't have the data or the visibility that I need to fix it. So I'm going to have to spend time debugging it, which takes time away from what I actually want to work on, which is new features. So there's no incentive for me to write more tests. By having this visibility, we've seen our development teams actually write better and more tests. Because now when tests fail, they actually have the visibility to understand why it failed, how it failed, and how to fix it. So how can you bring this notion of shift-left observability into your projects? And I'll cover some things high level, but again, I don't want to be too prescriptive on any of this. Hopefully I've given you enough examples of ideas that you can say, you know what, that would make sense for my teams, or maybe we don't really need that. First and foremost, it is actually very easy. And there is no right way, there's no wrong way to do it. As I mentioned, today you may be running blindly. You may not have a clue of what's happening prior to production. So some visibility is going to be better than no visibility. So don't leave this talk thinking, what Borja had all these graphs and all these ideas and Docker images tracking and the distributed traces. We need everything. Like grab one thing and work on that. Add that to your teams. Figure out, okay, what would we benefit the most? What's going to have the most positive impact to us and our teams? Start there and then move forward. Now, there are some commercial tools. Of course, I am biased towards Datadog solution here, but you can get started with a lot of open source tools. There's tools, test frameworks like PyTest and I believe also JUnit that automatically are able to produce metrics and traces with additional plugins. Tools like Ansible that also have the ability to create traces for OpenTelemetry. There's of course OpenTelemetry, the project itself for open standard around distributed tracing, and they're also adding logs, metrics, profiles, and more. There's tools like Jaeger that allow you to consume those distributed traces to see them. So Jenkins has the ability, has a plugin to also generate distributed traces out of your pipelines. So there's a lot of tools out there that allow you to start shifting left and bringing some of these observability ideas into your development workflow. That's all I had. Actually, no, I have one more joke. Why do programmers always mix up Christmas and Halloween? And I'll give you a clue. Halloween is on October 31st, and Christmas is December 25th. And these images were also created by Midjourney by simply saying Christmas, Halloween, by the way. Good job. Look at that. Great job. Actually, this was my favorite joke out of all the three. I think this one actually had some merit. All right, so with that, I will open it up for questions. And thank you so much for taking this time and coming to my talk.
Any question? No?
Thanks. Thanks for the great talk. Quick question. Time-wise, how long did it take for you and your team to reach the graphs which you showed?
That's a tough. It's not fair for me to say how long. So I've been in this space and thinking about these problems for many years. So it doesn't take that long. But what I do see other teams that don't have any visibility and move in this direction, days to weeks, depending on your current state in terms of observability. If you already have established observability best practices, tools, and processes for production and how you instrument your applications, then it's very easy to get started because you already have that foundation that is going to allow you to then instrument things in the development workflow and consume it through that same platform. If you're starting at a point where you don't have any observability platform, you're not able to consume metrics, logs, distributed traces, and such, then a little bit longer. But again, you can get your first graphs, you can get your first visibility within a day, really.
Okay, thanks.
Mm-hmm.
Yeah, great presentation, by the way.
Thank you.
Are you planning to do a new company after you leave Datadog?
As an entrepreneur, you're always thinking, but the truth is that
I can see you staying at Datadog after 2 exits.
I am very happy at Datadog. I am given opportunities to push the boundaries of and innovate on things that I'm truly passionate about. So for now, my head is at Datadog and solving developer problems within Datadog and for Datadog. Yeah.
Any others?
How do you persuade companies that it's worth investing in improving the developer experience? Because they might not necessarily see an instant outcome, so it can be difficult to sort of monetize. So what kind of arguments do you use?
That's a great question, and it is an order of magnitude easier to work with the companies and the teams that already believe this. And I think there is definitely a trend towards that direction, but at the same time, I do see a lot of challenges with companies that don't see that and where developers are, let's just say, disregarded, right? You don't want to enable them. So I think I saw the numbers. I saw the actual gains. DORA is something that I'm hearing more and more from a leadership perspective. So this is things that the leadership teams are, hey, somebody sent me a paper that said something about DORA. We have to have DORA because somebody said it. So that's a good entryway. It's like, okay, this is where you stand today. And then by implementing some of these best practices, you can actually have an impact on those numbers changing. There's things like space, which is another set of metrics that measure developer efficiency and happiness. So you can use those as well to prove that some of these initiatives will actually have an impact. My biggest, the way I've been most successful is by actually going directly to the development teams. If I go to a developer and I show them this stuff, it is most likely than not, they'll raise their hand and say, please, can we have this? So I use that as the power, the function, the forcing function to say, your developers need this. If I go again to a higher level up and show this, it's going to make developer lives easier, better, more productive, they're likely not to buy it. But having developers actually raise their hand and say, this will make our lives so much better, it's a good forcing function to get it. Does that answer the question?
You have also questions here. Maybe you can read from screen. There or there.
Do you know why Java programmers wear glasses? Oh, somebody's sending us jokes. I don't want to pull up Midjourney and do a prompt for an image in case there's something that we don't expect to show up. But anyone in the audience would like to take a stab at this one? That's a good one. That's a good one. So because they cannot C#. Next up, do you only use Datadog visualization methods to visualize metrics and graphs in your presentation, or do you use other tools? So in my presentation, the screenshots that I had, trying to think, I think all of them, maybe there's an exception here or there, but I think most of them came from Datadog. But that is not to say that they cannot be built with open source alternatives. So again, some of these visualizations using other open source tools. I mentioned Jaeger. You got things like Prometheus, some of the Elastic suite of products would allow you to have similar visualizations with open telemetry as the engine to collect distributed traces, metrics, and so on. So everything should be possible. Nothing that I saw is specific to Datadog, other than, yes, we do have a commercial solution that makes it very easy. But again, there are alternatives. And that's all the questions. Any other questions from the audience?
I have one, maybe.
Please.
I can ask. By the way, this tracing the continuous integration system is a brilliant idea. My question is, if it is, for example, our prod environment, we have the capacity, all the components are fixed. The only changing part is our application. We are changing it. If there is an anomaly, detecting is very easy. But when it comes to continuous integration system, the environment, it is not always something we control it. So let's say that there is a latency in the SQL query. It can be caused by, for example, GitHub Action environment. So do you think Datadog also produces false positive alerts for this, or any preventive mechanism?
There's going to be false positive depending on what you've done, implementation. Some tests, if it's an integration test, that depends on a third party. There will be latency, flakiness. As I mentioned earlier, it's not something that you will be able to eradicate completely. If you have a test that depends on the network, it's inherently flaky. Like there's just no way around it. The network itself is flaky, so the test will be flaky. I think it's just, going back to my earlier comment, some visibility versus no visibility. Would you rather not know at all, or would you have some false positives here and there? And then figuring out specifically on the use case how to mitigate it. Also figuring out the root cause, right? When you have visibility, you can identify the root cause. Is it a change in configuration? Is it the fact that maybe our CI infrastructure didn't provision fast enough? Is it an application issue? Is it related to the code change? So what we do is we have some signals that allow us to identify generally the idea or the area in which the issue may have surfaced, and we'll automatically, instead of pinging, entire Slack channel, we'll say, hey, this thing failed. We know who the code owner is for the specific test or for the specific file, and we'll send alerts that are targeted to that developer or to the platform team, depending on the root cause. So that allows us to, the first set of eyes that's going to look at the problem is likely the set of eyes that needs to be looking at that problem.
Okay, thank you.
That's an obvious question, right? Who is not doing AI these days? We're already doing explorations. I think it's one of those things where we do not know what we do not know, right? Like, what's the extent of where this can actually be useful and helpful? Adding AI, sprinkling AI for the heck of AI, I'm not a believer. I want it to solve actual problems. I want to allow me to do things that either I cannot do today, or allow me to do things that I'm doing today but do them better, right? So potentially, can it help with root cause? Can it help provide a solution, a fix? If I know that there's a flaky test, can I use AI to suggest how to get rid of the flakiness? So we're looking into all the explorations to understand, can we generate tests? Are those tests useful? We're running through the explorations right now, and it is a priority. I think it's something that's very important. We've seen the technology advance a lot in the last few months, so we definitely want to be pushing the boundaries as what's possible there. We're not discarding any option right now. There's limits. Some of these AI systems say that I want to send the entirety of my log dump for a pipeline. Maybe that's too much data, right? The token issue where, okay, maybe I cannot send all of that. So how do we work through that? Same with code bases. Do I send entirety? Do I send a section of it? How much context that the AI need to make that informed decision? So again, we're very much at that exploration process right now of what data do we send? What are we trying to get out of it? And again, does it ultimately actually serve a purpose that is useful for the developer, for the platform team? Thank you. One more? Don't be shy. Any more jokes? Thank you so much.
Okay, thank you for a great.